In this tutorial, we'll be looking at interfacing a character display with the AVR Atmega32 microcontroller. Now, these displays you should have seen in many places, and you probably want to have it in your project so that you can display messages on it, and it is quite useful for a microcontroller based project because it is one way to get to see what the controller is doing. You can display messages and see what is going on inside, or it could be the primary display of a project where you want to tell everyone what is going on. So let's see how we can interface this. Now, so this is the display. So it comes in various sizes, and even the backlight has various colors like the blue, green, and all of that. Now, in this some of these, like in this tutorial, we'll be using 16 cross 2 display. So this, okay, will be using a 16 cross display, but the way it works, it applies for most of the displays like the 16 cross 1 or 20 cross 4. So what I mean by 16 cross 2 is there are 16 characters on one line, and there are two such lines. Similarly, the 16 characters just on one line, and there are 20 characters on 4 lines. So these comes in various sizes. Now the LCD itself, or the display itself, has a small controller. So this is what you can see on the back side. So this controller, it's usually HD44780, and it is used in almost this, or a compatible controller is used in most of these character displays. Now, if you want to know as to exactly how this display works, if you're curious to know how it takes commands, how it glows these matrix patterns and creates or generates these patterns on a display, I would recommend you to watch two videos which you made to explain how it works in detail. But if you're really concerned only to get this working, and if you want to display messages and get going with it, just watch the video. Or if you want to know details about how it works internally, watch the two basics videos. Alright, so let's go ahead and see how we could use it with AVR. So this is the internal structure of this particular character LCD. So the place where it displays all the characters, it's called the LCD panel, and this is the controller. So, and this is the actual interface that is given outside for a microcontroller or for any other device to interface with this particular character LCD. So what you can see here is there are data lines DB0 to DB7. So this is a parallel display. So you have 8 lines just to transmit data, and there are some other pins which you will see in detail. Now let's go ahead and look at the pin diagram. So as you could have seen here, so this is pin number 1, if you see, and this is pin number 16, and all these pins are also described on the back of the display. So let's just go ahead and look at the pin diagram. Now, okay, so basically what you have here is the data lines. So these are 8 data lines, DB0 to DB7, and this is followed by a backlight. So the LED has, the LCD has a lot of LEDs on the back panel, and it helps us to see the letters even when it is dark. So these LEDs, these need to be powered. So this is LED anode and LED cathode. So usually what is done is LED anode is tied to 5 volts, and LED cathode, so it depends on the display, it is tied to ground through a current limiting resistor. So the resistor value usually depends on the manufacturer. In some of the LCDs you do not require this at all. So, and you could also use this particular, it is as good as having a LED inside, so you can use this pin to even control the backlight. So say it is a daytime and you do not want the backlight to be turned on, you can control it with these two pins. Usually it is connected in this fashion. Now let's move on to the other pins. So these two pins are the ground. So this is VSS is the ground and this is VCC. So VCC, again, it's usually connected to +5 volts to power this up. And what you have on Vout is, so Vout is the contrast pin of the LCD. So with this pin you can control the contrast, and usually what is done for this is it is connected to a pot, so or a potentiometer. So this is, so one side of the potentiometer is connected to VCC and other side is connected to ground. So by VCC I mean 5 volts, because we're using a 5 volts controller. So if we change the contrast, change the potentiometer here, the contrast of this changes. Now these are three important pins which determine how the LCD communicates with the controller. So the first pin that you have, that is the pin number 4, it's called the register select. So if register select is 0, the LCD is ready to accept commands from the microcontroller. Okay. And if it is 1, it accepts data. Now what could be possible commands for an LCD? So the commands usually are to set the cursor position, or to clear the display, or go to a particular position on a display. All these are commands for the LCD. And what could be the data? The data usually is the ASCII values of your characters. So you can display characters, numbers, and even some special symbols. So all these is data. So whenever you want to send a command, the register select line should be 0, and if you want to send a data, actual data that needs to be displayed on the LCD, the data should be, the register select line should be 1. The next what we have is read/write bar. So this is RW. So usually it's RW, just RW. So the way I remember it is, so this is read/write bar. So if it is 1, or let's say if it is 0, then we are writing to the LCD. It means controller is sending the commands and LCD is accepting it. So we are writing into the LCD. And if it is 1, we are reading from the LCD. Now this is the normal operation. So we write commands, we write data. Right. So the write, this is usually in the write mode, and this pin is 0. But you can also read back from the LCD. So when would that be helpful? One instance is since this LCD is a very slow device compared to a microcontroller. So what happens is, when you send a data to be displayed, or assume you send a character to be displayed on LCD, it takes some time for it to actually display it on the LCD panel. So in order to know if that has finished displaying the command, you can read back from the LCD, and that is usually called reading the BZ flag, just to know if the LCD has completed displaying a particular character or command that we had sent. So this is about it. And there is one more pin which is called the enable pin. Now this enable pin, what is this used is, this enable pin, it is used to latch commands or data onto the LCD. So usually what you do is, we send a high to low pulse. So we keep the data on the data bus, we select whatever operation we need, and then we send a high to low pulse. So what this does is, this latches the command into the LCD. Now, so with these basics covered, let's see how we can possibly interface this. Now before we go ahead, I would like to tell you one more thing. So if you if you look at this, there are the data lines are DB0 to DB7. So instead of using all the 8 lines, we can use only 4 of them. So that mode, when we use only 4 lines, it's called the 4-bit mode. And remember, once we had done a board, and instead of connecting, we thought any of the 4 pins would work, and we later discovered that only DB4 to DB7 work in 4-bit mode. So just remember that whenever you want to save some pins on a microcontroller, use the higher 4 pins of the data bus. And the normal mode, when we use it in 8-bit mode, all the 8 lines are used. Now also, you could infer one more thing here. Like, say I do not want I want to save one more pin, and usually I do not read back from the LCD, so I just write. So what I could rather do is I can connect this read write pin to ground, so it will always be 0. Now with this particular combination, like say I used 4 pins for data, then I read write pin from the LCD, I just simply ground it, so I do not use it. So I just need to use register select and enable. So these are 2 pins. So totally the minimum IO pins you require on a controller to work with the LCD is 6. So there are again serial LCD options which work on I2C or SPI, but if you're using a parallel display like this, which are pretty common, pretty cheap, the minimum pins that you require is 6. Alright, so let's go ahead and look at some of the commands first. And sending data is pretty simple, so you just need to learn how to send commands. And if this is not clear to you, okay, sorry for that. So what we'll do here in this tutorial is we'll interface it in 4-bit mode. Now assuming that I've done all the connections, and so we just need to figure out the interface connections. So I'll be interfacing it on port C. So this is port C. 0 would be register select, port C1 would be read write, and port C2 will be enable. And the D4 to D7 would be port C4, port C5, port C6, and port C7. So this is basic simple interface, and I'll be demonstrating it on the starter AVR development board, which already has all the rest of the connections. So for your reference, the schematic is put on the tutorials page. The link is in the video description. You can check the schematic as well. So let us go ahead and look at the basic commands to set up the LCD. So here you go. So what you could observe straight away is observe this register select line. Okay, so for all these commands, so all these are all commands. So this command clears the display. This command sets it to the home, it takes the cursor to the home. This will discuss in length the entry mode set, and then this is again a few other commands. So what you could observe is the register select line is always 0 in all these commands. So what this means is these are all commands that we are transmitting. You can see that it becomes only 1-2 times. So this is when you write the data to the LCD, right? So either you write data or either you read data from the LCD. So only during that time it becomes 1. And same with the read write this thing. So usually we write to the display from the controller, so it's always read/write bar, it's always 0. Only if you're reading the busy flag, so this only during that time it becomes 1, and if you are reading data, only in this case. Alright, so let us go ahead and look at some basic commands. So clear display, it's pretty simple. So this B0, if we make the bit LSB bit as 1, it clears the display. If we make the B1 bit 1, it takes the cursor home. And now for this you need to watch the basics video. Now let me just go to the main command here. So this just, it turns on or off the display. It's display shift. Again, this is descriptive command. So this is an important command which sets the function. Now DL, it stands for display or interface length. So what that means is, so whether you want to use it in 4-bit mode or 8-bit mode. So if it is 0, it is 4-bit mode, and if it is 1, it is 8-bit mode. Similarly, this N stands for number of display lines. So if it is 0, so if this is 0, it's it's a 2-line display. If it is 1, it's a single line display. And again, the font size, you can have it in 5x8 or the other 5x10 type of display matrix to display a character. So if you want to know more about these commands, just watch the in-depth video. So this is where we extract the commands from. So this is the commands table and we extract the commands from. So let us go ahead quickly, write a simple program, and I'll be showing you how to use the Explore Embedded library, how you can input it in your project, and how you could interface such a display. Okay, so this is the, if you open a new file, this is how it would look. So I just created a project with the main file display .c, and then if you want to include say LCD library or UART library, what you need to do is you need to copy those files into this directory where you have created the project, and then you need to right click here and click on add and click on existing item. So usually all our libraries, they come with a C file and a header file. So include both of them, and when you do that, you will see these files here. Now let us go ahead and quickly look at two basic commands. Now what you usually need to do is you need to send either a command or a data. So that is just sending a single ASCII character. So let us go ahead and look at that function. Okay, so these two basic functions are used by all of the functions in order to display data. Now one thing you could observe is, since we are connecting only 4 lines, how could we send a command which is 8 bits? Okay, so what we do is we split it into 4 bits each, and these are called nibbles. So we send the higher nibble first, and then we send a lower nibble. Now in order to send a command, as you know, the register select line should be 0. So what we do here is we have made the register select line as 0, and then we have made even the read write line as 0. And before we even give these commands, we keep the higher nibble on the data bus. So higher nibble on the data bus, and then we send an enable pulse. So we wait for some time, and then similarly we send the lower nibble. Okay, so this is how we send a command. Similarly, to send data, a single character, what we do is the only change in this and the previous function would be register select. Since we are sending data register should be selected, and to send selected data register we use this. We set the register select to 1. So we send the higher nibble again, and we send the lower nibble. So with these two commands, you can build on top of all these two commands to display anything you want on the LCD except the custom characters. So we'll cover custom characters in another video. Now in order to use this LCD, you need to know one more function. So this is LCD initialize. So what it does is it resets the LCD first, and then it sets the data direction for the LCD bus, and then it sends all these commands. So it sets the LCD in 4-bit mode, it turns on the display, it turns on the cursor, it clears the display, and then it moves the cursor to first line, first position. So with this, the LCD is ready, up and running. So next what we do is we go ahead and type some messages that are required to display. So let's just go ahead and see how we can include it. So this is the basic IO file for the controller that we have used previously. Then to include a custom library file, you need to include the header file. So you should also observe I have included the lcd.h file, so you need to include that. And since it's in local directory, you just need to put it in double quotes, lcd.h. Okay, so this is it. And what we have in lcd.h is all the function prototypes. So all these functions are defined in lcd.c, and you have the definitions here. Okay, now so this is it. So these are the functions that we require, and then let's type the main. Okay, and so what we simply need to do is we need to initialize the LCD first, and then what else do we need to do? I guess there's nothing more. So we initialize the LCD, and then say we want to display a string. Okay, and there's one more function which takes you to the second line. So go to line 2, and then I will display something else. So let's say explore embedded. That's all. So what do we do after that? Don't do anything, just wait there. Okay, so this is pretty simple. This is how you include the library file and use the functions, and you should be up and running. So let me just build it. And before you go ahead and do this, the one important point as to how do you configure the port where you want to connect the LCD. So you go to lcd.c file, and here we show you the picture, and then so the port on which we have LCD, it's called port C, and even the control bus, the register, select, read, write and enable pins, these are also on port C. So we use the 4 pins, port C4 to port C7 for the data bus, and then register select is on pin 0, read write on pin 1, and enable on pin 2, as we have discussed previously. So after doing this, you just build the project and transfer the hex file. Oh, we made an error here, so I missed a semicolon. Yeah, so let's see. Is there anything else missing? Okay. Okay, I forgot to put while 1 here. You could put while anything that way. Okay, so if I build this, it builds, and then I'll transfer this to the starter AVR board. It has connections already done. The LCD is on the board, so I need not make any connections for this video. So I'll just go ahead, flash this on the controller and see what we get. So just fiddle around with the display, interface it in 4-bit, 8-bit modes, use busy flag without busy flag. All the libraries are available on the tutorial page, and the description on the link is in the video description. So thank you for watching. See you next time. Alright, so I transferred the code and I did a mistake. So instead of go to line 2, it was go to line 1. So just correct that in a code. Now let's see what we have on the display. We do not have anything. So if you are hooking up this for the first time, okay, so this might happen to you. So what you need to do is you need to set the contrast, and as described, so we have a pot here which varies the contrast. So what you do is, even before transferring the code, set the contrast so that you have square blocks on the LCD. So when you transfer the code and you set the contrast, you will see the message on the display. Alright, so you can also, if you're using the Ultra Development Kit, or if you're hooking up your own circuit, do check out the demo on the Ultra Development Kit, which is linked at the end of this video. So thank you for watching. See you next time.